The humble BS 1363 square pin plug and socket outlet is an absolute marvel of engineering that leads the world in quality and safety. However, when we get into slightly rougher and more dangerous environments, they're no longer quite enough to do the job. Enter the BS EN IEC 60309 round pin industrial plug and socket. It's robust, secure and quite necessary in certain areas as defined by BS 7671. To help you understand the requirements and the changes made by the Second Amendment to the 18th edition, we created a free training package to help you with your CPD. This is the video from that training package that we've decided to release to our wider audience. We really hope it helps your understanding of this subject, and if you'd like to complete the course and receive an accredited certificate to count towards your annual CPD requirement, then please click the link in the description below to take you to the relevant webpage. Industrial socket outlets have a seriously broad range of applications, from warehousing to agricultural installations. So what do we need to think about when specifying this kind of outlet? In this CPD presentation, we're going to look at some of the critical regulations that we'll need to bear in mind and illustrate those regulations by means of these RCD socket outlets from Lewden. The first question is, does the socket outlet require RCD protection? Well, let's turn to BS 7671 and we're going to look at regulation 411.3.3. Now, this is one of the regulations that had some changes made to it under the Second Amendment. So let's have a read and see what it says. In AC systems, additional protection by means of an RCD with a rated residual operating current not exceeding 30 mA shall be provided for 1. Socket outlets with a rated current not exceeding 32 amps in locations where they are liable to be used by persons of capability BA1, BA3 or children BA2, BA3. Now this is interesting as it's the first time the regulations have mentioned specific types of people in the context of this subject, these being BA1, which refers to ordinary or uninstructed persons, BA3, which represents disabled people, and BA2, which indicates children. We'll discuss these codes a little later in the video, but for now it's enough to say anywhere these types of people are to be found, then socket outlets up to and including 32 amps in rating must be protected by an RCD that has a residual operating current no higher than 30 milliamps. The regulation continues. 2. Socket outlets with a rated current not exceeding 32 amps in other locations. And 3. Mobile equipment with a rated current not exceeding 32 amps for use outdoors. Now, if you look at that regulation carefully, it seems a bit oddly structured at first because Indent 2 seems to cover all locations. So why is there a clearly defined reference to types of people in Indent 1 if they're already covered by Indent 2? Well, it's because there are certain circumstances where you cannot install an RCD, as defined in the next part of the regulation. An exception to 2, but not 1 or 3, is permitted where a suitably documented risk assessment undertaken with the involvement of a skilled person electrically determines that RCD protection is not necessary. So there you go. If a risk assessment is carried out and finds that RCD protection isn't needed, then you don't have to install an RCD to a socket outlet. However, this doesn't apply to places used by ordinary people, the disabled, or children. These still require the RCD and the risk assessment option doesn't apply. So that pretty much rules out vast swathes of electrical installations. The regulation also states that the documented risk assessment shall be provided with the appropriate electrical installation certificate. So bear in mind, this is not just a case of saying, well, it doesn't need an RCD. There has to be a specific reason and proof in the risk assessment to show why it's not required. And that risk assessment will stay with the installation certificate and have your name on it. So if anything goes wrong with it, you'll need to be able to justify your decision. There's also an interesting new note there with regard to the risk assessment option that says, Note 1, for the purpose of this exception, an ordinary person, BA1, instructed in the use of the installation, does not become an instructed person electrically or cease to be an ordinary person. This made me smile when I read it because it reminded me of when the increased requirement for RCDs was first brought into the regs. I think it was Amendment 2 of the 16th edition. Back then you could train someone using a facility to become an instructed person and remove the need for RCDs that way. Basically it meant helping them understand how not to drill through cables. This note very clearly shows that this isn't an option now. In fact, even back then, the facilities manager of one of our large commercial customers had this option explained to him and instantly said, no, just RCD everything. Clearly, he was a keen student of human nature. Are there any other circumstances where you may need to install RCD protection to a socket without exception? Well, If we turn to section 704, we can see there that this is the section that covers the special location of construction and demolition site installations. Now, this section is covering installations that some may class as temporary. However, many elements of construction sites remain in place for a long time, and this type of socket outlet could be absolutely perfect for this kind of install. We find a couple of different options for socket outlets in regulation 704.410.3.10. It states, a circuit supplying a socket outlet with a rated current up to and including 32 amps and any other circuit supplying handheld electrical equipment with rated current up to and including 32 amps shall be protected by 1. Reduced low voltage, regulation 411.8, or 2. Automatic disconnection of supply, section 411, with additional protection provided by an RCD having the characteristics specified in regulation 415.1.1, or 3. Electrical separation of circuits, section 413, each socket outlet and item of handheld electrical equipment being supplied by an individual transformer or by a separate winding of a transformer, or 4. Selve or pelve in section 414. Now, indent 3 of this regulation does get used, but very, very rarely on construction sites by the use of an isolating transformer. Indent 4 is in the mix as well when you think of the prevalence of battery-operated power tools on site. But indent 1 is far and away the most common. It refers to regulation 411.8, where we find in 411.8.1.2 that the nominal voltage of the reduced low voltage circuit shall not exceed 110 volts AC RMS between lines, which in a single phase circuit gives 55 volts to the earth midpoint of a transformer. And here you can see an example of a 110 volt socket outlet that could form part of a 110 volt system on a construction site. However, going back to section 704, we can see that in indent 2, we can see there that, and this may come as a surprise to some, using a 230 volt supply is completely acceptable on a construction site according to BS 7671, as long as it has RCD protection complying with regulation 415.1.1, which basically states that we would need to use a 30 mA RCD for additional protection. So again, we can see there that this outlet providing 30 mA RCD protection could potentially be used for a construction site. Casting our eyes over the page to another regulation that was updated in the Second Amendment, namely 704.511.1, we can see it splits sockets into two different categories where previously there was only one. It reads, plugs and socket outlets with a rated current of 16 amps up to 125 amps shall comply with the requirements of BS EN 60309-2. Plugs and socket outlets with a rated current exceeding 125 amps up to 800 amps and where interchangeability is not required shall comply with BS EN 60309-1. So this now divides the socket ratings into two parts to reflect the changes made in the standards in 2022. So if you want to find out if the outlets comply with the right standard, then the simplest thing to do is just to go and check the manufacturer's data sheets. And you can see here on this socket outlet that it complies with the relevant standard. We find a similar requirement for RCD protection in a number of other places in the regulations. For example, in section 705, which covers agricultural and horticultural premises, we find regulation 705.411.1, which states, in circuits, whatever the type of earthing system, the following disconnection devices shall be provided. Indent 1. In final circuits supplying socket outlets with rated current not exceeding 32 amps, an RCD having the characteristics specified in regulation 415.1.1. So again, we see there that 30 mA rating. Just a little tip as well, I always find the expression not exceeding a little confusing, so mentally I tend to replace it with up to and including. So instead of reading not exceeding 32 amps, I read it as up to and including 32 amps. It just makes much more sense to me that way. And in this regulation from section 704 we read earlier, you may have noticed it was worded in exactly that way. It's also worth noting the second indent of that regulation, which states, in final circuits supplying socket outlets with rated current more than 32 amps, an RCD with a rated residual operating current not exceeding 100 milliamps. So a higher residual operating current of RCD can protect sockets rated at over 32 amps, but bear in mind that's up to 100 milliamps. So a 30 milliamp will still comply while providing additional protection. While we're in section 705, if we look over at regulation 705.512.2, we read that in agricultural or horticultural premises, electrical equipment shall have a minimum degree of protection of IP44 when used under normal conditions. Where equipment of IP44 rating is not available, it shall be placed in an enclosure complying with IP44. So again, a socket outlet like this one must have at least an IP rating of 44. The first 4 being protection against foreign bodies not less than 1 mm diameter. And the second 4 being protection against splashes of water from any direction. However, the regulation goes on. Where there are conditions of external influences greater than AD4, greater than AE3, and or greater than AG1, socket outlets shall be provided with the appropriate protection. External influences are things that will have an impact on some part of our installation. So where do we find information on these external influences? Well, they're in Appendix 5 of BS 7671. We see there from the first page that the opening letter refers to the category of external influence, either environment, utilisation, or construction of buildings. The second letter relates to the nature of the influence, and the number relates to the class within each external influence. Over the page we have the list of external influences. So the first influence mentioned in the regulation in section 705 was AD4. So the A at the start means it's environmental in nature. The second letter, D, in this case relates to water, and the numeral 4 indicates splashes. So the regulation stated that where conditions greater than AD4 apply, we need to provide appropriate protection to the wiring system. So if the environment presented external influences of AD5, AD6, AD7 or AD8, we'd need to provide appropriate protection. What protection? Well, again, over the next few pages, we find tables containing detailed information on each external influence. So if we flip through till we find the relevant code, so let's say in an agricultural environment, there may be jets of water from hose pipes giving us an external influence of AD5. Looking across to the characteristics column, we find there that we need to provide protection of IPX5. One key point to bear in mind for IP ratings, though, is that they're only cumulative up to IPX6, meaning that if a piece of equipment has IPX7 written on it, that doesn't automatically mean that it's rated at IPX5. Good manufacturers will provide this information clearly. As you can see here on this RCD protected socket, it actually lists all the specific IP ratings that it's been tested to. Just one more interesting example here is that our original regulation from section 705 made reference to external influence AG1, which relates to mechanical stress caused by impact. And if we go above this to AG2, which indicates medium severity, we find that industrial equipment needs to be used, and beyond that, we'd be looking at AG3, which is high severity, and reinforced protection would be required. Again, looking at this range of equipment from Lewden, we can see we've got various levels of mechanical protection here, from standard plastic enclosures to GRP glass reinforced plastic enclosures, all the way up to metal cased sockets. Again, providing the ability to give the correct level of mechanical protection in the correct environment. Now this becomes extremely relevant in connection with regulation 705.513.2, where we read, electrical equipment generally shall be inaccessible to livestock. Equipment that is unavoidably accessible to livestock, such as equipment for feeding and basins for watering, shall be adequately constructed and installed to avoid damage by and to minimise the risk of injury to livestock. So if you absolutely cannot avoid installing an electrical socket near livestock, then you'll need something from the more impact resistant end of this range. Another area for special consideration when it comes to socket outlets is in section 708, which relates to electrical installations in caravan/camping parks and similar locations. Regulation 708.415.1 states, every socket outlet shall be individually protected by an RCD having a rated residual operating current not exceeding 30 milliamps. Devices selected shall disconnect all live conductors. So again, we see that important requirement for RCD protection, but also the requirement that the device will disconnect all live conductors. So in the single phase outlet for a caravan pitch, that means both the line and the neutral conductors need to disconnect when the RCD protection operates. So that may mean, as in this case, you've got this double pole RCCB providing that element of protection. Another interesting detail for caravan sites is here in 708.55.1.1, which states that every socket outlet or connector shall either comply with BS EN 60309-2 and shall be interlocked and classified to clause 6.1.5 of BS EN 60309-1 to prevent the socket contacts being live and accessible, or be part of an interlocked self-contained product complying with BS EN 60309-4 and classified to clauses 6.1.101 and 6.1.102 of BS EN 60309-4 to prevent the socket contacts being live when accessible. Now, we won't get bogged down with individual clauses in BS EN 60309. The key point is that the sockets need to be interlocked with the plugs, meaning that you can't connect the power to the socket outlet without something plugged in. Basically meaning that these terminals here can never be both accessible and live at the same time. We find similar requirements to those discussed already in section 709, marinas and similar locations, but with some interesting tweaks. Regulation 709.531.2 states, socket outlets shall be protected individually by an RCD having the characteristics specified in regulation 415.1.1. Devices selected shall disconnect all poles, including the neutral. Now, did you spot a difference in this regulation? There's no upper limit on the current rating of the socket, so no not exceeding nor up to and including here. Also, as expected, we see higher requirements for IP ratings for water here, as we can expect the external influences of water in a marina to be more hazardous, as shown in regulation 709.553.1.8, where it states, every socket outlet shall meet the degree of protection of at least IP44, or such protection shall be provided by an enclosure. Where the codes AD5 or AD6 are applicable, the degree of protection shall be at least either IPX5 or IPX6, respectively. So when installing socket outlets to these areas, we'd look for RCD protection even on higher current rated outlets and make sure we were installing equipment with the relevant IP requirements. Now, another area where you may need to use this kind of socket outlet is at perhaps trade shows and the like. Section 711 of the regs covers exhibitions, shows and stands. And the previous regulation, 711.411.3.3, has now been moved and updated to regulation 711.410.3.101 and gives us that now familiar requirement that final circuits not exceeding 32 amps supplying socket outlets can use a 30 mA RCD for additional protection, but also applies the same principle to handheld equipment and lighting circuits, but not circuits feeding safety circuits. It also outlines other options, including SELV or PELV or electrical separation. There's an interesting point in regulation 711.410.3.4, which states that a cable intended to supply temporary structures shall be protected at its origin by an RCD whose rated residual operating current does not exceed 300 mA. This device shall provide a delay by using a device in accordance with BS EN 60947-2 or be of the type S in accordance with BS EN 61008-1 or BS EN 61009-1 for selectivity with RCDs protecting final circuits. Exhibitions are often set up to be quick to install and take apart and so rely heavily on plug and socket connections. So you may have one big outlet that feeds many other smaller ones, and that main connection must have RCD protection up to and including 300 mA. But even with a higher rated RCD, you can still run into selectivity problems whereby a fault on an individual final circuit can operate the RCD on the distribution circuit, leading to a loss of power to healthy circuits. Therefore, the residual current device for the distribution circuit needs to incorporate a time delay in order to overcome this potential issue. Similar requirements to those already discussed can be found in section 717, mobile or transportable units, section 730, onshore units of electrical shore connections for inland navigation vessels, and section 740. Now in section 722, which relates to electric vehicle charging installations, we find an interesting situation. We've got very used to manufacturers producing dedicated charging units with all kinds of clever gadgetry for power monitoring, remote activation and energy control. However, we tend to forget about regulation 722.55.101.0.201.1, easy for me to say, which states, each AC charging point shall incorporate, indent 2, one socket outlet or connector complying with BS EN 60309-2, which is interlocked and classified to clause 6.1.5 of BS EN 60309-1 to prevent the socket contacts being live and accessible, or indent 3, one socket outlet or connector complying with BS EN 60309-2, which is part of an interlocked self-contained product complying with BS EN 60309-4 and classified to clauses 6.1.101 and 6.1.102 to prevent the socket contacts being live when accessible, which is very similar to wording to what we read in connection with the socket outlets for caravan pitches, and basically tells us that you can charge an EV up from a normal socket outlet with the correct adapter, and making sure that the charging lead has the box of tricks required to control current flow. Of course, if you're connecting to a PME earthing facility for outdoor charging, you need to comply with one of the indents of Regulation 722.411.4.1, but it can still be used for EV charging. The outlet itself needs to comply with Regulation 722.531.3.101, which states, unless supplied by a circuit using the protective measure of electrical separation, each charging point incorporating a socket outlet or vehicle connector complying with the BS EN 62196 series shall be protected individually by an RCD of Type A, Type F or Type B and having a rated residual operating current not exceeding 30 mA. It then goes on. Except where provided by the EV charging equipment, protection against DC fault currents shall be provided by 1. An RCD Type B or 2. An RCD Type A or Type F in conjunction with a residual direct current detecting device complying with BS IEC 62955 as appropriate to the nature of the residual and superimposed currents and recommendation of the manufacturer of the charging equipment. So this outlet has an interlock to make sure the terminals can't be powered up when nothing is plugged in, again preventing contact with live parts. It can also contain a Type B RCD. Of course, this is due to the increasing amounts of DC current that are being injected into our AC systems by various loads, and these can prevent RCDs from operating correctly under earth fault conditions. Now, this is particularly a problem with charging electric vehicles, so the B-type RCD can operate correctly even when higher levels of DC are being injected into the system. So hopefully from this CPD presentation, you've seen some of the things that you'll need to bear in mind when selecting the correct type of outlet for industrial sockets. Things like impact ratings, IP ratings, plus specific regulations if they're being installed into certain special locations. And we can also see that no matter where they're being installed, Lewden have a product that fits the bill. We hope that information was helpful to you, and once again, if you'd now like to complete the training package by answering a few multiple choice questions, then please click the link in the description below, and do please check out the rest of our free training packages on the know-how page of our website efix.co.uk. All that remains in this video is to say thank you very much for watching.